Now the important question, what should be the shuffle partition number? By default it is 200, and almost in all the cases 200 is a wrong number. So what should be the shuffle partition number? But before that, let's do a recap of the input partitions. We know how to calculate the input partitions. It would be the file size divided by 128 MB or file size divided by 4 MB if the file size is less. Of course, you can change 128 MB to something else, which we'll discuss in the next section. Then you have shuffle partitions, and this is what our focal point is. The default value is 200 and it is almost always non-optimal, meaning that you should always change the value of spark.sql.shuffle.partitions, which is used to control the number of partitions. So what should be the value of Spark SQL shuffle partitions? This is what it should be. Post shuffle, individual partition size should be less than or equal to 200 MB. What it means is that whenever the shuffle reader is reading data from a particular partition, the size of that partition should be less than or equal to 200 MB. So when I say less than or equal to 200 MB, what is the minimum size? So it should be anywhere between 100 to 200 MB. That should be the post shuffle partition size. So if you see that the shuffle writer has written 800 MB of data, and you know how to find that out using the Spark UI, looking at the action, and here we have the stages, and this is the shuffle write and this is the shuffle read. So you know what would be the size of the shuffle write data. So in this case, 362 MB is the shuffle read data. So Spark SQL shuffle partitions value should be 2 only, not 200. So this is the best practice, and you should remember this, that post shuffle individual partition size should be less than or equal to 200, minimum of 100 MB, not less than that. So it should be anywhere between 100 MB to 200 MB. Now how do you find out what is the post shuffle total data size? You can go to Spark UI and look at that shuffle write. So after you do that, then only you set the parameter Spark SQL shuffle partitions to whatever value you find out to be. You have to do the testing once and then you have to set the value of Spark SQL shuffle partitions. So the number of shuffle partitions should be less than equal to the shuffle stage data size divided by 200 MB. So the shuffle stage data size is the size of shuffle writer and shuffle reader or shuffle reader. The size of shuffle write data and size of shuffle read data would always be equal. So the number of shuffle partitions would be that data size divided by 200 MB or maybe 100 MB. And there is one more condition that we'll have to check, which is the number of shuffle partitions should be always greater than equal to number of cores in the cluster. So in the previous example, I had told you that value of the shuffle partitions parameter should be 2. That is not correct, because what we are doing is that we are using 4 executors and each executor is getting 1 CPU. So the value of the shuffle partitions, which is Spark SQL shuffle partitions, should be 4. So these are the 2 conditions that you have to check. First is the size of the shuffle data divided by 200 MB or 100 MB. So it should be anywhere from 100 to 200 MB. This is the first condition. And the second condition is that number of shuffle partitions should be always greater than equal to the number of cores in the cluster. So in our case, wherein I had used standalone cluster, I only allocated 4 CPUs for 4 executors. That's why I mentioned 4. If your cluster has, let's say, 16 CPUs, then it should not be less than 16 CPUs. Spark.sql.shuffle.partitions should not be less than 16, irrespective of what the number of partitions you get out of this and this. So it should be a max of these 2. And then we have output partitions also, which we'll talk about in the next section. But there are operations like repartitioning and coalescing, which can be used to change the output partitions. So I just wanted to give a heads up about output partitions because that is the next topic of discussion. But I hope you got an idea to find or to calculate what should be the number of shuffle partition be, or what should be the value of spark.sql.shuffle.partition should be. Now I'll be revisiting the Spark Shuffle and Join application that I had written. So this is the application Spark Shuffle and Join, and it took 14 seconds. If you open the application, these are the various jobs. So two loads for the loan data, two loads for the customer data, and then finally save, wherein we have 212 tasks. So if I open this job ID 4, there should be two stages, or three stages rather, because it involved joins. The first one is shuffle writer for loan data. The second one is shuffle writer for customer data, or the other way around. And the final one is post shuffle stage. And this is how the DAG looks like. We have already seen this. And the reason I'm talking about the join transformation and will be using the join transformation again, because I want to do some experimentation with spark.sql.shuffle.partitions parameter. So as you already know that by default, the number of post shuffle partitions should be 200, and that is always non-optimal. That is not optimal. So what we'll do is that we'll use the formula that I had shown you and set the value of Spark SQL shuffle partitions based on the formula. And then let's see what is the execution time, whether it changes or not. Just in case, the execution time, the previous execution time was 14 seconds. Okay, now before setting up the shuffle partitions, let's look at the shuffle output size. And the total output size is 362 megabytes. So as I had told you that the number of partitions, a single partition should have anywhere from 100 to 200 MB of data. And also at the same time, the number of shuffle partitions should not be less than the number of cores. So what am I doing here is that I'm using 4 worker instances and 4 executors. Each executor is having 1 CPU. So I'll consider the size to be 100 MB. In that case, I will set Spark SQL shuffle partitions to be 4. Right, so it should not be less than the number of cores that I'm using for my Spark installation. In our case, it is 4. So I'll be setting the Spark shuffle partition value to 4, and let's see what the output is. Then I'll set it to maybe 2, and then we'll see what the execution time is. By the way, I have named it as experiment Spark shuffle partitions and maybe _1, because I'll do 2 experimentations. This is the loan file. I'm reading it from the loan folder, finance loan folder, and the second one is from finance customer data. It is as simple as that. And now what I'll do is that before even executing this, let me go ahead and set the value of Spark SQL shuffle partitions to 4. And how do you do that? In the previous code, I had shown you that you can use spark.conf.get to get the value of a particular variable. To set the value, you'll have to use spark.conf.set, and then the name of the configuration, which is spark.sql.shuffle.partitions, and let's set it to 4, and you have to put it in quotes, by the way. And then let's print the value just to confirm that it actually worked. And you know how to print the value. You'll have to use the spark.conf.get API. Okay, now after that, let's look at the number of partitions before writing it. So I'll not be writing it this time. I'll just check the number of partitions. So first would be the input partition for df underscore loan. Second one would be the input partition for df underscore cust data frame. And the third one is df underscore join, wherein a white transformation is happening. And I'll try to get the number of partitions. So let's print all these before even writing it to the file. So as you can see, the number of shuffle partitions have been changed to 4. So this is the first one, the first print statement. The second print statement is the input partition for df loan, which is 4. That is correct. The third one is input partition for df customer, which is 8. That is also correct. And then df underscore join, which is the final one. Now this time it is only 4. Why? Because I have changed the configuration parameter value of Spark SQL shuffle partitions to 4. Now let us go ahead and write it and see whether there is any difference in the execution time or not. By the way, I have deleted all the previous output file so that we can start afresh. So let's execute this. and it took 12 seconds, a little less than 14 seconds. And if I open this application, as you can see, the tasks or the number of tasks have changed drastically. We have 1, 4, 1, 8 and 16, not 208 anymore. And these two saves actually ran in parallel. It's the same DAG visualization, nothing changes because it is a join. And here I have the shuffle writer for customer, shuffle writer for loan, and then shuffle reader for the post shuffle stage. And it is reading 356 MB of data. And you can also find the time that was taken for individual jobs. For the first one, it was 0.6 seconds, then 2 seconds, 42 ms, 2 ms, and the save wherein we had multiple stages, we had 3 stages, it took 5 seconds. Let's look at what were the numbers last time. So it was 6 seconds instead of 5 seconds, right? All right, so this is what we have gained, a very nominal amount of performance by reducing the shuffle partitions. Now what will I do is I'll name the application to be 2 and I'll increase the shuffle partitions to be 8. And let's see what happens. What is the execution time? Now let's execute this with 8 shuffle partitions. With 8 partitions, it took a little bit less time, 11 seconds. And let's go inside of the application. And as you can see, the save actually took lesser time. The first time it was 6 seconds. And when I changed the shuffle partitions to 4, it took 5 seconds. And when I changed the shuffle partition to 8, it took 4 seconds with the same number of stages and a little bit higher number of tasks. Now I'll do 2 more experimentation. One would be with 2 and the other one would be with 16. So first let me change it to 16 and execute this again. I forgot to change the name of the application. It took 11 seconds. No changes as such. It took 4 seconds only, right? So if you keep the post shuffle partition size to be anywhere from 50, 100 to 200 MB, beyond that, you might not get too much of performance improvement. In the last one, I'll change it to 2. In 2, the shuffle partition would be 180 MB. And let's execute this last time and see what is the execution time. Again, I forgot to change the name of the application. That's okay. And with 2, it took 12 seconds, just like 4. And if I go inside, I think it will take 5 seconds as usual. So the shuffle partition size should be anywhere from 100 to 200 MB. And this time around, the experimentation that I have done, it is using a smaller file size. If your file size is way bigger, then you might see different execution time for your application. If you ever run into performance issues with Spark jobs, especially ones that just seem to hang forever, chances are that it had something to do with the shuffle partitions. And in this video, I have broken down why shuffle partitions matter and how they impact performance and what you can tweak to make your Spark jobs run smoothly. And by the way, if you're the kind of person who learns best by doing, building real world data engineering pipelines and seeing how these concepts play out in actual projects, I have linked one of my go-to resources in the description, Project Pro. Their Spark projects walk you through scenarios where tuning shuffle partitions isn't just theory, it's the difference between success and a job failure. I have put the link in my description.